This is the start of TK Academy, where the T and the K stand for Team Knowledge. This is a core competency course, which is a refresher of the basics that every architect and designer should know, and the topic is construction budgeting. A project budget drives more decisions than probably anything else during the design and construction of a new building. In this course, we are going to explore what are cost drivers for a construction project. We will explain what the differences are between project cost and construction cost. We'll look at what are considered project hard and soft cost. Then we'll identify key cost components that contribute to construction cost and the approximate percentage of each within the total cost. Finally, we will identify 4 major methods of preparing cost estimates. Success of any project, regardless of how large or small, depends upon the team and how well the participants work together to achieve the intended results. Every project team has the same fundamental goals: that the project meets the owner's requirements and is constructed safely, on time, and on budget. To achieve the goal of the project being completed on budget, the project cost must be considered, and the budget updated and revised during each step of the project, but especially during the early phases of project conception, project delivery and procurement strategy, and budget development. The project starts when someone conceives of an idea. The project conception is the first stage of any building process, and it is when the project budget should first be developed. The steps involved with the project conception include doing due diligence investigations, which involve consideration of whether the project is viable, supported, and needed. It will be determined where the project is going to be located and what sites are available. The project's facility program should be established to determine how large the project is going to be and what type of spaces are going to be included. Will the project have unique performance requirements and functional aspects beyond the typical building components? Finally, what is this all going to cost, and is it financially feasible? Whether a project is public or private, all projects start with a preliminary budget or funding amount that the owner has established. Many owners are experienced and will have project management staff dedicated to developing a project scope and budget. Those who are not experienced in this area will likely choose to hire an architect or project manager for the programming, planning, and the initial project budget development. The method in which a client chooses to procure design and construction services will make an overall impact on the project budget. We refer to this as the project delivery method, and it impacts how a client chooses to set up the contractual relationships within the team. The 3 primary means of project delivery are design bid build, which is also referred to as the traditional method, design build, and early contractor involvement, which is often referred to as construction manager at risk, or CMAR, or construction manager general contractor, or CMGC. A private client may choose to procure design and construction services by any means that they wish. They may choose a competitive selection based upon specific criteria developed by the owner, or it may just be a direct award to a team of the owner's choosing for a negotiated fee and price. Publicly funded projects will typically go through a competitive process to ensure the lowest cost and best value possible for taxpayers. Many public clients will allow for other procurement methods such as design build and early contractor involvement, but the traditional design bid build delivery method tends to be the most prevalent in public work. As projects start into design, it is easy for clients and designers to lose focus on the project budget. As the team begins envisioning what the project can be, it is extremely easy for a project to run past its original project budget and to increase beyond what the client can afford. That is why it is so important that throughout the project design, the anticipated cost of the work should be continuously monitored and updated. Building cost analysis encompasses the economics of cost estimation and management. It must be reevaluated at each phase of the design process and counted against what the initial scope, the project goals, and the requirements for the design. During the first stage of pre-design, the team determines the programming of required spaces and functions of the project and what the actual needs are versus wants. This phase establishes the baseline for the project size and budget. Schematic design is the exciting part where we start to envision what this project can be and what it could look like. The anticipated cost of the work should be continually monitored during this phase, especially compared to the building area and square footage. During design development, specific materials and systems are selected. The building footprint area should be set. The building foundations and structure are known. There is substantial information in the design to determine a realistic cost estimate. The final phase of the design, the construction documents, is where the cost estimate starts to become fixed and the only minor changes occur. It becomes very difficult to influence cost at this stage. The project schedule is initially developed during the project conception and refined through the design and construction process. A project schedule should consider all stages of the project, as well as anticipating potential delays from the length of the approval process and permitting, economic factors, and weather conditions. Time is money, and schedule delays can cause financial impacts for the owner, designer, and contractor. An important concept for a client to grasp is how the project budget is related to the project schedule and how costs are impacted by timely decisions. Decisions made early in the conceptual phase will affect the following subsequent project phases. As a project develops in each phase, each major change will equate to more pressure exerted on the project budget. Decisions are easier to implement and less costly the earlier they are made. As the project time goes on, decisions that are made will be more difficult to implement and will have greater significant impact on the project budget. Up to this point, we have been referring to all cost as being the project cost, but this should not be confused with the construction cost. Construction costs are those costs incurred by a general contractor related to the physical construction of a building, including the materials, labor, equipment, and the contractor overhead. There are many additional costs that are beyond just the cost of the building. These are the project costs, and they include the construction cost as well as those additional costs incurred by the owner to fully implement the project. We separate these into project hard cost and soft cost. Hard costs are associated with the cost of constructing a building and make up about 80% of the entire project budget, while the remaining 20% are considered soft cost. Typically, hard costs include the direct cost of construction, which is mostly labor and materials, but it could also include the cost of site preparation, utility relocations and tap fees, temporary stormwater management and erosion control measures, waste disposal and landfill charges, equipment rental and operational cost, temporary heating, and contractor overhead and profit. The soft cost associated with the project can make up about 20% of the overall project budget. Soft cost generally includes costs that are less tangible, such as due diligence studies, programming, and master planning of the project. Site surveys and soil analysis are commonly required project soft cost. The architecture and engineering design fees are considered soft cost, as well as the building commissioning. There may be jurisdictional costs associated with the project, such as rezoning and permitting. A newly constructed building will require to be furnished before it is usable, which is referred to as outfitting or providing the fixtures, furniture, and equipment, or FF&E. Personnel and staff may need to be relocated and could involve moving expenses, as well as costs associated with terminating existing leases and rental agreements. Almost every decision made, from project conception to construction completion, will affect the project budget. Any change in the scope of work or definition of what services are being provided is going to directly equate to the change in project cost. Buildings are three-dimensional objects, so the building area footprint and height are both significant factors to the project cost. It is always easier to build out than up, so taller buildings lead to higher cost with additional structure necessary of achieving heights, additional vertical conveyance to circulate people throughout, and increased emphasis on worker and equipment safety during construction. Changes to programmatic factors like occupancy and use can affect cost, even with no change in room size and area. For example, if a space was originally planned as an office space at $300 a square foot, and now it is going to be repurposed as a laboratory at $800 a square foot, obviously there would be a cost impact to that decision. Design factors will weigh in on the cost of a project. Changing the building orientation, its geometry, exterior and interior articulations such as windows and doors, quality of finishes, the inclusion of additional projections that may provide shade such as canopies and roof overhangs, will all impact the project budget. As designers, we strive to always be mindful of the building aesthetics with the goal of providing excellent design, but this must be balanced with the limitations of the construction budget and what the project can afford. Decisions that are made outside of the scope of design will also affect the project cost. Clients are faced with decisions that are legal and administrative in nature that will influence the project budget. We discussed earlier how the project delivery method selected and utilized can impact the budget, but also the timing of the construction contract award can come to bear on the project cost. If time is of great concern and a client decides to prematurely award a construction contract prior to the completion of construction documents, not only is the client introducing greater risk, but there could be additional costs needed to revise the design and redo work during construction. There are economic factors that are outside of a designer's or contractor's realm of influence, such as unstable and turbulent market conditions with growing inflation that can lead to escalation in building material and labor costs in ranges often within 10 to 20% higher than normal. During a recession, prices tend to drop, and construction materials and labor are readily available. New competition may come into the market and drive competition upward for both construction materials and skilled trades. Limiting competition by not going through a competitive process or by having a limited number of qualified bidders in the subcontractor pool can result in higher project cost. Projects with more risk will cost more. Contractors do not assume risk, they bid risk. Risks are simply transferred back to the client in terms of cost. The more risks that are present within a project, the greater the cost the project is going to be. As emphasized earlier, construction cost is not the same as project cost. The cost included in construction will include all the costs associated with constructing the project. This may include construction materials, labor, tools and equipment, bonds, permit fees, insurance, and maintenance agreements. During the project conceptual phase, the cost is a rough estimate typically based upon area unit cost known from a previous construction project. As the project develops through the design phase and the scope becomes more defined, the actual construction cost becomes more evident, but it will not be completely known until the project is bid or negotiated. Even then, the full cost of construction will not be known until the project is complete, as there will likely be changes and modifications that are made through construction. Construction costs typically fall within the categories of materials, labor, equipment, and contractor overhead costs. Materials, labor, and equipment are those hard costs associated with the construction project. Overhead refers to the soft costs that are required to support the construction project. With materials, there is the cost of the materials themselves, but there is also additional costs associated with it, such as taxes and shipping. Construction labor typically makes up about 50% of the construction cost. There are the direct cost of labor compensation, but there are also additional overhead costs such as payroll taxes, insurance, premiums, and fringe benefits that also account for the labor expense. Equipment will be required on site such as cranes, excavators, and forklifts, but there can be other equipment costs for operational needs such as providing temporary heating to the facility during cold weather conditions. Overhead costs cover the general operations and management associated with a construction project, such as having field supervisory and project management staff. It may involve specialty consultants such as field engineering, material testing, and commissioning agents. The cost of temporary facilities and temporary utilities are included in the overhead cost. The goal of every project is to complete the project safely without injuries, so there are the costs associated with having a safety program and safety equipment. There are bonds, permits, and insurance costs that are associated with completing a project. Every construction project will also include a limited amount of contingency for unknown and uncontrolled aspects of work that will affect the project. Material costs are directly impacted by what is designed and included in the construction drawings and specifications. The material costs include the direct purchase of materials, local and regional taxes, shipping and transportation, and temporary storage and securing of materials. There may be unique limitations on the procurement of materials, such as many federal projects that require that materials be sourced and manufactured within the United States. Sustainable projects often have unique requirements for materials, such as local materials, recycled content, environmental declarations, and low VOCs that may have a premium cost over other materials. Costs can also involve additional fees for custom engineering and fabrication of specialty materials. Once materials are procured and delivered to the project site, it takes skilled workers to put those materials in place. It requires both labor and equipment to install materials. Labor makes up most of the construction expenses. Labor costs can include the base wages of employees, but also include associated expenses such as payroll taxes, insurance benefits, workers' compensation insurance, overtime pay, and temporary housing. Installation costs are often driven by geographical variations, such as the available labor pool. Certain trades will carry higher insurance premiums based upon the risk, like demolition and steel framing. Insurance premiums can also be affected by the contractor's safety record. The equipment cost will include the direct cost of the equipment, whether that equipment is owned, purchased, or rented, and the operational cost, including any additional support staff and maintenance required for that equipment. Site limitations will affect productivity, especially on additions and remodels, if the building is to be occupied and in use during construction. Access and egress routes must be maintained continuously when the building is occupied. The contractor must have an area for laydown and staging of materials, and this is often limited in certain environments more so than others. This laydown will include other necessary spaces such as job trailer and places for workers' parking. There are multiple variables that affect the construction cost, making it difficult to establish a static and fixed budget. Purchase prices vary based upon fluctuations within the market. Materials could be procured locally, but contractors will likely consider a larger regional market to get more competitive prices. Regional markets can offer different products, which can affect project goals differently. For example, if it is a sustainable project that is pursuing LEED certification, there may be a goal of purchasing materials with a certain percentage of recycled content. Timing and sequence of construction activities also significantly impact the construction cost. Weather plays a factor, as it is typically more difficult to build a project during cold weather than it is during warm weather. However, even in warm weather conditions, the heat and sun can cause limitations on timing and the hours that can be worked. Long lead time for products can often cause delays or additional expenses in having to procure the materials or equipment in a reasonable time for installation. Shipping costs depend upon where the materials need to come from and how quickly they need to arrive on the site. During the project design, the estimate preparation and information will change based upon the level of development of the project. These changes will require estimates to be prepared at different levels during the design process, with increasing degrees of information provided. It should also be noted that within each level of estimate preparation, not all portions of the design would be at the same level of completeness. For example, the architectural design may be at 80% complete, while the mechanical design is only 50% complete. This is common through the design process, but should always be noted in the estimate narrative. There are 4 primary methods used to estimate construction cost. Those methods are known as parametric cost estimating, area and volume estimating, assembly and system estimating, and unit price and schedule estimating. Each method is appropriate depending upon the level of design, and each method of estimating offers a level of confidence that is directly related to the amount of time required to prepare the estimate. Parametric cost estimating is often used in the early planning stages when little information is known about the design other than the overall project parameters. Parametric estimation is a quantitative technique that involves using historical cost data to develop mathematical models. Project comparison estimating uses historical information on total cost from past projects of similar building type. This estimating method requires an assumption of an approximate gross area for the proposed work and a sufficient historical record of similar building types. The greater the number of prior project combinations for which scope and prices are known, the the more accurate the parametric cost estimate will be. This method has no better than a 15 to 25% accuracy. The area and volume estimating method is effective in preparing fairly accurate estimates if the design is developed enough to allow measurement and calculation of floor areas and volumes of the proposed spaces. More accurate estimates made within this method should include adjustments for regional cost, local labor market rates, and interpolation between available cost tables. Further adjustments may be made to account for other unique aspects of the design, such as special site conditions or design features being planned. Estimates made within this model can be expected to be within 5 to 15% accuracy. Assemblies or systems estimates group the work of several trades or disciplines and work items into a single unit for estimating purposes. For example, a foundation usually requires excavation, formwork, reinforcing, concrete, placement, finish, and backfill. An assembly and systems estimate provides a lump sum price for all these elements together by applying values available in assemblies cost data guides. These guides are based upon historical databases, typically organized in the Uniformat system. Estimates made within this method can be expected to be within 10% accuracy. In single unit rates estimating, the work is divided into the smallest possible work increments and a unit price is established for each piece. That unit price is then multiplied by the required quantity to find the cost of the increment of work. Finally, all costs are summed to obtain the total estimated cost. This method of estimating provides the most accurate means of projecting construction cost, but it can be time-consuming and may require input from various stakeholders. Escalation refers to the inflationary cost growth anticipated between the time an estimate is prepared and the time a project bid is accepted. Escalation cost is added to move the projected pricing forward in time. From the estimation date to the projected bid date, an estimate would be escalated for that given time. Contractors and subs should include an escalation in their cost, with guarantees given for a limited time. An example would be a contractor agreeing to hold their bid price for 60 days. During construction, a cost estimate can assume that 50% of the work will take place during the first half of the construction schedule. Therefore, a cost estimate may be escalated to reflect the midpoint of construction to provide a realistic cost of the whole construction effort. Contingency is an allowance for work that is unknown or not completely defined when the project is estimated, but is anticipated to be included in the scope of work. Contingencies can be assumed and applied to the cost estimate for various reasons. Design contingencies are applied based upon the level of completeness of the design documents and the estimator's confidence that the design will not change significantly from what was used in the preparation of the estimate. Estimating contingency amounts can reflect the estimator's confidence in the estimate and the availability of adequate information. Insufficient information typically covered by estimating contingency amounts could include the level of design completion, availability of building materials and labor, site access, and conditions of work such as new versus renovation. Construction contingencies are meant to cover unknown conditions such as weather, unexpected delays, and variances in the existing site conditions. Owner's contingencies are intended to cover allowances for scope increases or owner-selected changes. A design contingency is an amount set aside to allow for flexibility during the design process. It covers unforeseen costs and unknowns that can arise while developing the project design. It acts as a buffer to address changes in scope before the final drawings and specifications are completed. Design contingency amounts depend upon the completeness of the design when the estimates are prepared, and the degree of confidence the estimator has that the design will not change significantly. This helps ensure that the project stays on budget and can adapt to unexpected challenges. Robert Snow Means was a civil engineer who kept meticulous construction cost records in a series of leather-bound books he made at his kitchen table. By the early 1940s, His peers were so impressed with his tracking of material, labor, and equipment cost, they began offering to buy his homemade cost books. The legacy of R.S. Means lives on and has become synonymous with detailed construction cost data. The R.S. Means database contains cost information for most common construction materials, labor, and equipment, and cost engineers continuously research, validate, and update this cost information. The R.S. Means cost information is still available in books, but is more commonly accessed in a digital database. The Tri-Service Automated Cost Engineering System, known as TRACES, consists of a suite of software applications designed to support the cost engineers working on military projects. TRACES is managed by the U.S. Army Engineering and Support Center in Huntsville, Alabama. It provides a standard suite of automated tools used for the preparation of planning and budgetary estimates, for analysis on budget cost data during design, and captures cost data for historical purposes. The TRACES modules include the Parametric Cost Estimating System, known as PACES, Microcomputer Aided Cost Estimating System, second generation, often referred to as M2, Cost Book, Unit Price Book information, Area Cost Factors, Historical Analysis Generator, and Cost Risk Analysis, commonly referred to as Crystal Ball. The Parametric Cost Estimating System, known as PACES, is a software application used for preparing parametric construction cost estimates where little or no real design has been developed. PACES utilizes construction criteria and pre-engineered model parameters to generate construction cost estimates. Quantities can be changed at various levels within models to reflect project-specific conditions. Parametric modeling minimizes errors and omissions associated with traditional cost estimating procedures, particularly during the planning and early design phases. The Microcomputer Aided Cost Estimating System, second generation, more commonly referred to as M2, is a software application used by the U.S. Army Corps of Engineers and architect-engineer firms for the preparation of detailed construction cost estimates on government projects. The software can be used for the preparation of project cost estimates at various stages of project development. The Unit Price Book is a database containing construction cost data for different cost tasks. The cost book is used by the M2 software for the development of line item cost associated with a project cost estimate. In summary, when assessing the construction cost of a project, there are several key factors that should be considered. Clearly defining the project scope from the outset helps identify all elements that are required within the cost estimate. Understanding site conditions to account for potential challenges that may impact construction cost, such as difficult terrain or existing structures that need demolition or renovation. Complex and intricate designs often require more resources and expertise during construction than simpler ones. Understanding material requirements and associated cost is essential for accurate estimation. Additionally, considering different labor rates based upon location or specialized skills. Including contingency funds within estimates accounts for unseen circumstances or changes during construction, and recognizing fluctuations in material prices and availability alongside industry trends. This completes our course on construction budgeting. Thank you for participating in TK Academy. Please give this video a thumbs up or feel free to leave a comment. You can subscribe to TK Architecture on YouTube for additional videos and courses.